right, so today we're doing Chapter 1, Lesson 1, and that is factors and multiples. And for this first lesson, you guys, we're going to break it up into the greatest common factor, and then tomorrow we'll cover the least common multiple, okay? So the first thing that I ask you to do is write down the definitions of the highlighted vocabulary. So the greatest common factor says here it's the greatest of the common factors of two or more numbers. That's the GCF. The least common multiple, which is what we're going to talk about tomorrow, is the least non-zero number that is a multiple of two or more whole numbers, and that's the LCM, least common multiple. Now, it says here a common factor is a number that is a factor of two or more numbers. Now, do you guys know the difference between factors and multiples? Okay, so a factor, that is a number, like the numbers that you multiply to get another number. So, for example, 2 times 3 is equal to 6, right? So 2 and 3 are factors of 6. Does that make sense? All right, very good. So here, number 1 says, copy the statements listed below, and then we're going to follow the directions here. So these are the factors for 32 and 90. 32 and 90. So now we're going to circle all the factors that they have in common. So we can see that we've got 1s in common. We've got 2s in common. Anything else? Nope, nothing else. Now the third question is, what is the largest of all of the common factors? The largest is 2. That's the largest. So that tells me that my GCF, oh, I got a new mouse, it's going crazy, is equal to 2. So we want to find the greatest common factor. So I want you to write this down. Write down your heading, your title, and I want you to write down that you can use common factors or prime factors to find the GCF. Now here, in addition to writing down this rule here, or this note, I want you to write down the definition of the prime numbers. Okay? It says a prime number is a whole number that has exactly 2 factors, 1 and the number itself. Okay? So a prime number, for example, is 2. 2 is a prime factor because, a prime number, because the only factors of 2 are 1 and 2. Those are the only 2 numbers you can multiply together to get 2, right? 3 is a prime factor because the only 2 numbers you can multiply, the only 2 whole numbers that you can multiply to get 3 are 1 and 3. What's the next prime number? Okay, there's 7 is 1, but it's not the next one. Right, very good. So 5 and 7, those are both prime numbers. Is 1 a prime number? Let's see, what are the factors of 1? 1 times 1. Are those 2 factors? No, it's just 1, right? It's just 1 factor. The number 1 and itself. It's still 1, right? So 1 is not a prime factor. Is everybody clear with that? Please make sure you write that in your notebook. So for this first example, it says there's 1 slice of serving for 3 types of cake on each table. Each row has an equal number of servings and only 1 type of cake. What is the greatest number of servings in each row? Now remember, this is one where you're just watching and listening. You don't have to write this one down, okay? So here, to solve this problem, we're going to use common factors, and we're just going to list them, just like we did in the warm-up, okay? So for 10, it's 1 and 10, 2 and 5. Then for 15, we have 1 and 15, and 3 and 5. For 20, it's 1 times 20, 2 times 10, and 4 times 5. Okay, remember the finger thing. You know, you don't have anything else in between. Okay? Then it says the GCF of 10, 15, and 20 is 5 because they have 1 and 5 in common, and 5 is the greatest. Okay? Now, I want to tell you, when you're listing your factors, you're always going to have 1 as a common factor, right? Okay, so 1 will never be, if 1 is your common factor, okay, then there is no, that's the greatest common factor, then you're just going to have to multiply the numbers together, okay? All right, so let us do this example together. So it says, Lana earned $49 on Friday, $42 on Saturday, and $21 on Sunday selling bracelets. She sold each bracelet for the same amount. What is the most she could have charged for each bracelet? So here, my important numbers are how much she made on each day. So you can write those down. And we want to know what the question is asking us. So it says, what is the most she could have charged for each bracelet? So in order for us to solve this one, we are going to find our greatest common factor. Okay? So for 49, we've got 1 times 49. Make sure you leave a big enough space in between. And we have 7 times 7, right? Now, when you have 7 times 7, of course, we're just going to write that 1 time. Is everybody with me? Then we have 42. So for 42, we've got 1, let me put this arrow, 1 times 42, 2 times what? 21. 2 times 21. 3? Yeah, 3 times. So 3 times 14. And let's see, 4? No. 5? No. 6? Yeah, 6 times 7. Very good. 6 times 7. And those are our factors for 42. And then we have 21. So for 21, we've got, of course, 1 times 21. 2? No. 3? Yeah. So 3 times 7. Anything else in there? Nope, that's it. So we have 1, 3, 7, and 21. So now we can go ahead and we can circle the ones that they have in common. So we've got 1s in common. What else do we have in common? We have 7s in common. Anything else? Nope. Which one is the greatest of those two? Of course, 7 is the greatest. So our GCF is 7. 7 what? Dollars. Very good. So that is the most she could have charged for each one of the bracelets. All right. So now you can use prime factors also to find your greatest common factor. Now I'm going to show you 2 different ways. I'm going to show you the factor tree like this, and I'm also going to show you this thing that we're going to call it the cake method. The reason we call it the cake method is because there's just layers. You know how like cake has layers, right? All right. So here, this is the factor tree. This is the factor tree. So when we are finding the prime factors, the numbers that you can multiply together, the prime numbers that you can multiply together to get 12, this is how we do it. And we just break it down. So 12 can be broken down to 6 times 2, right? It can also be broken down to 4 times 3. You with me? Okay? So I'm going to do I'm going to do 12 over here. You can write this part, you can write this down if you want to. We can do 4 times 3. Now, are all of those numbers in this row prime? No, the 4 is not prime, right? So we can break that down some more, okay? So 4 can be broken down to 2 times 2. Very good. And then, of course, we always want to bring down what's left over. So see here, 2 times 2 times 3, and 2 times 2 times 3, we ended up with the same thing. Whether you break it down 6 times 12 first or 4 times 3, 12, as long as you are continuing to break down with prime numbers, you'll end up with the same prime factorization in the end. You got that? All right. So now I'm going to show you the cake method for 18. Okay? So for 18, this is how we do that. So here's 18, and we're going to do like an upside down division problem like that. Okay? And we want to know what is the smallest prime number that can go into 18. 1 is not a prime number. We can do smaller than 3. 2, okay? So let's do 2. So now we're just going to divide this. So 18 divided by 2 is 9, and we're going to put that down below, okay? And then we want to know what's another prime number that can go into 9? 3. So that's going to be 3, and 9 divided by 3 is 3. Now, once you can't divide any more prime numbers in there, then this is your prime factorization. So for the cake method, this is your prime factorization. 2 times 3 times 3. And then for the factor tree, the bottom row is your prime factorization for 12. Is everybody clear? All right. Then, of course, what you're going to do is you're going to multiply the factors that they have in common. So here we've got, bless you, the 2's in common and a 3 in common. You see that? The 2's are in common and the 3's are in common. So to get the greatest common factor, you're just going to multiply 2 times 3, which is equal to 6. You got that? All right. So let's do B, C, and D together. These are the ones we're going to write down in our notes. All right, so for example B, for problem B, let's use the factor tree to do this one, okay? So we've already broken down the 12. Whoops. We've already broken down the 12. We're just going to show our work again, okay? So 12 we can break down to 2 times 6 or 4 times 3. So 4 times 3, either one is fine. And then the 4 can be broken down to 2 times 2. And then we're going to bring down that 3. Okay? 66, what can we break down 66 to? So 6 times 11. And then the 6 can be broken down to? Beautiful. So 2 times 3. And then bring down the 11. So you're always going to have a final row there, okay? So now we want to circle what they have in common so that we can multiply them together. So we've got a 2 in common, and what else do we have in common? A 3 in common. So there's a 3 there. Anything else? No? So in order for us to get our greatest common factor, we're going to multiply 2 times 3, and that's going to give me 6. Okay. Let's do letter C using the cake method, okay? All right. So for letter C, oops, let me just draw a line right here so you can see the separation. Okay, so this is B, C is over here. So we've got 18. Oh, look at that. We broke down 18 already too, didn't we? So, I know somebody wanted to start with 3 before, and I said, no, 2. Let's try 3. Okay? So, we're going to first break down 3 into the cake, into the 18. So, 18 divided by 3 is 6. And then, what can I divide into 6? Prime number. 2. And then that's going to be 6 divided by 2 is 3. And so that's done, right? And then let's do 30. What can we break 30 into? Okay, we can do 5. So 5 times 6. Very good. And then 6 can be broken down to 2. So 6 divided by 2 is 3. And then we're done. Now, I do want to tell you that I would like for you to start with the smallest prime number. Okay? Start with the smallest prime number. So now that's done. So now we can circle what they have in common. So let's see. We've got a 2. And we've got a 3 in common. So, oh, look at that. GCF again is 6. 2 times 3 is 6. Does everybody see how I'm showing my work? Okay? And I know that these first problems, they're very simple, but they're going to get a little more challenging. So you have to learn it with the simple so that you can do it with the more challenging. Is everybody clear? All right. So let's do letter D down here. Okay, for example D, let me just draw this line right here. For example D, we're going to break down 32. So let's do 32 with a factor tree and a cake. Okay? So let's do 32 with the factor tree and then 48 with the cake. Okay? Just so we can practice both. Okay? So 32. What can I break 30? What times what equals 32? Okay. So, and for some reason I always put the smaller number in front. Okay? And then, what does 4 break down to? 2 times 2. Very good. So 2 times 2 times, what can 8 break down to? 2 times 4. Are they all prime? Not yet. What else can I break down? The 4, right? So this 4 can be broken down to 2 times 2. And then we're going to bring down those other 3 2's. Okay? All right, so now let's do 48 with the cake. All right, so what prime number can I divide into 48? Okay, 2. So 48 divided by 2 is 24. All right, so what can I divide into 24? I want a prime number. 2. So 24 divided by 2, 12. See, with the factor tree, it doesn't matter if it's prime, right? But with the cake, you have to divide the prime numbers in. Okay? So, what can I divide into 12 now? All right, 2 again. So that's going to be 6. And then what can I divide into 6? 2 again. And then 6 divided by 2 is 3. Very good. So now, let's look at what they have in common. So here we've got a 2. We've got another 2. Whoops. We've got, let's see, let's use purple. We've got another 2. And let's use orange. And we've got another 2. So, to find our greatest common factor, what am I going to multiply? 2 times 2 times 2 times 2. Very good. Now, when we multiply this, you can multiply in any order, right? So I'm going to do 2 times 2 is 4, and then over here 2 times 2 is 4, and then I'm going to multiply 4 times 4 is 16. Very good. So my greatest common factor is 16.